Welcome back to the real number system. In this video, we're going to talk about algorithms for adding. So let's get started. You'll notice as we go through today's video, we're going to look at 6 different algorithms. And you may be wondering, why do we teach so many algorithms? Well, we don't expect children to use all of the algorithms in real life. But the algorithms do help children develop understanding of what we do when we add. And some algorithms will work better for some problems, while other algorithms work better for other problems. You'll notice as we go through these algorithms, they do build upon each other. So let's get started. First, we have our base 10 blocks, or sometimes this is called the concrete model. The concrete model uses set theory. Now remember, from our previous section, our base 10 blocks have units, longs, flats, and blocks. Remember, 10 units make a long, 10 longs make a flat, and 10 flats make a block. We're going to add using our base 10 blocks. So we have 55 plus 69. Well, 55 can be written as 5 longs and 5 units. And 69 can be written as 6 longs and 9 units. This gives me a total of 11 longs and 14 units. Now remember, 10 units make a long. So I'm going to exchange 10 units for a long. And we'll have 4 units left and 1 extra long. That gives me a total of 12 longs and 4 units. Well, 10 longs make a flat. So I exchange my 12 longs for 2 longs and 1 flat. This gives me 1 flat, 2 longs, and 4 units. The flats represents hundreds, so we have 100. The longs represent our tens, so we have 20. And then we have 4 ones, or 4 units, which represents 4 ones. Next, we're going to add 674 and 938. Well, 674 would be 6 flats, 7 longs, and 4 units. 938 is 9 flats, 3 longs, and 8 units. When I add, I get 15 flats, 10 longs, and 12 units. Now I need to make my trades. 10 units is the same thing as 1 long. So I trade 12 units for 1 long and 2 units. This gives me 15 flats, 11 longs, and 2 units. 10 longs is the same thing as 1 flat. So I exchange my 11 longs for 1 flat and 1 long. This gives me flats, 1 long, and 2 units. Finally, remember that 10 flats is a block. So I exchange 16 flats for 1 block and 6 flats. This gives us 1 block, 6 flats, 1 long, and 2 units. The block represents the thousands place, so we have 1,000. The flats represent the hundreds place, we have 600. The long represents the tens place, so that would be 10. And then the 2, the units, represent the ones place. So we have 1,612. Our next algorithm is called the expanded algorithm. The expanded algorithm focuses on place value. Here we're going to add 55 and 69. We're going to start with the ones place. So we add 5 plus 9, which is 14. Then we move to the tens place. That first 5 represents 50, and the 6 represents 60. 50 plus 60 is 110. When I add these together, I get 124. Now we have 674 plus 938. Again, we're going to use the expanded algorithm to add. Start with your ones place. 4 plus 8 is 12. Then move to your tens place. The 7 represents 70. The 3 represents 30, and 70 plus 30 is 100. Move to the hundreds place. The 6 represents 600. The 9 represents 900. 600 plus 900 is 1500. Then add each of your places. We have 2 in the ones place, 1 in the tens place, 1 plus 5 is 6 in the hundreds place, and 1 in the thousands place, for 1,612. Our next algorithm is the standard algorithm. This may have been what you used when you learned to add. You may have learned the term carrying in addition, but the words we commonly use now are regroup and trade. The reason we use the words regroup or trade is because they more closely match the physical actions that we do with the manipulatives, the base 10 blocks that we looked at in that concrete model. This helps students understand place value, and it helps them relate the standard algorithm to that concrete model, which gives them a better understanding. So we have 55 plus 69. 5 plus 9 is 14. I regroup or I trade, and I have 4 ones, and I trade for a 10. Notice the 1 that I added in the tens column. Now add the tens column. 1 plus 5 plus 6 is 12 for 124. Here we have 674 plus 938. Again, we're going to use the standard algorithm, and notice that I'm going to use the words trade or regroup rather than the term carry. 4 plus 8 is 12, so I trade. I have 2 ones, and I add a 10 to the tens column, and add your tens column. 1 plus 7 plus 3 is 11. Now notice I have a 1 there, and I'm going to regroup or trade and add a 1 to the hundreds column, because 10 tens from the 11 gives us an extra 100 in the hundreds column. 1 plus 6 plus 9 is 17, so we have 1,712. Again, we focus on regrouping or trading. So 4 plus 8 is 12. I trade for 2 ones and a 10 that I added to the tens column. 1 plus 7 plus 3 is 11, but I have to regroup or trade. So I trade 11 tens for 110 and 100 in the hundreds column. Then 1 plus 6 plus 9 is 17. Our fourth algorithm is our left to right algorithm, or partial sums algorithm. This method also emphasizes our place value. Now you'll notice that this method is very similar to our expanded algorithm. The difference, though, is in the expanded algorithm we move right to left. So in the expanded algorithm we start with the ones place every time. But in the partial sums algorithm we'll start with the leftmost digit. So here we have 554 plus 698. We're going to start with the leftmost place. So that 5 represents 500, and the 6 represents 600. 500 plus 600 is 1100. Then move to the tens place. The 5 represents 50, 9 represents 90, and 50 plus 90 is 140. Then move to your ones place. 4 plus 8 is 12. Add the thousands place. We have a 1 in the thousands place. Add the hundreds place, gives us 2. The tens place we have 5, and the ones place we have 2 for 1,252. Next we have 674 plus 938. Again, using the partial sums algorithm, we move from left to right. So we'll start with the hundreds place. The 6 represents 600. The 9 represents 900. 600 plus 900 is 1500. Next, move to your tens place. The 7 represents 70. The 3 represents 30. 70 plus 30 is 100. And then last we have the ones place, 4 plus 8 gives us 12. In the thousands place we have 1. In the hundreds place, 6 when we add. 1 in the tens place and 2 in the ones place for 1,612. Our next algorithm is called the lattice algorithm. This may be very different from any algorithm that you've seen before. We end up with a lattice at the end of our problem, and we add along the diagonals of the lattice. So let's look at this so you understand what I mean when I talk about a lattice. We're adding here 5,543. Now you'll notice as I wrote these, I left a little extra space between my digits. You'll see why here in a minute. Then we have 6,982. I'm going to draw a box underneath my addition. I'm going to add columns for the thousands, the hundreds, the tens, and the ones. Next, draw a diagonal from the bottom left to the top right in each of your boxes. Then we're going to start with the ones place. 3 plus 2 is 5, or you may see that written as 0, 5. So you have 0 tens and 5 ones. 4 plus 8 is 12. The tens place goes in the top triangle. The ones place goes in the bottom triangle. 5 plus 9 is 14. Again, the tens place goes in the top triangle. The ones place goes in the bottom triangle of that box. And then 5 plus 6 is 11. So the tens place goes in the top triangle. The ones place goes in the bottom. Then we're going to look at each of these diagonals along the lattice. So at first, we have just 5. In the next diagonal, 0 plus 2 is 2. The next diagonal, 1 plus 4 is 5. Then the next diagonal has 1 plus 1, or 2. And the last diagonal is just a 1. This gives us 12,525. Let's look at another. In this problem, we have 6,742. Now notice again, I left some extra space between my digits. This is going to give me some extra space for that lattice when I add. I'm adding 9,389. Draw a box underneath your addition. Draw your columns for your thousands, hundreds, tens, and ones place. In each of those columns, we're going to draw a diagonal from the bottom left to the top right. Then we add each of our places. So 2 plus 9 is 11. The tens digit goes in the top triangle and the ones digit goes in the bottom triangle. 4 plus 8 is 12. The tens digit goes in the top triangle. The ones digit goes in the bottom triangle. 7 plus 3 is 10. Again, the tens digit goes in the top triangle. The ones digit goes in the bottom. And 6 plus 9 is 15. The tens digit goes in the top triangle. The ones digit goes in the bottom triangle. Add along the diagonals. So we have 1. The next diagonal, 1 plus 2 is 3. In the next diagonal, we have 1 plus 0, or 1. Then 1 plus 5, or 6. And finally 1. For a total of 16,131. Our last algorithm is called the column addition algorithm. In this algorithm, we'll have columns for each of our places. And many times you might see the base 10 blocks used in this algorithm. Write down each of your places. So we have the hundreds place, the tens place, and the ones place. For our first number, we have 2 hundreds, 4 tens, and 3 ones. Then the next number has 6 hundreds, 8 tens, and 2 ones. Add each of the columns. So we have 8 hundreds, 4 plus 8 is 12 tens, and 3 plus 2 is 5 ones. If you think about our concrete model, we couldn't have 10 of anything, or we had to make some trades. We would trade 10 units for a long or 10 longs for a flat and so on. The same type thing happens here. Notice in the middle column I have 12 tens. Well, 10 tens makes an extra 100, so that gives me 9 hundreds in the hundreds column, and I'm left with 2 tens. And then I have 5 ones. And our answer here is 925. So again, you'll notice in blue the trade that I made. I traded 12 tens for 2 tens and 100. 8 plus 1 gave me 9 in that hundreds column. Let's look at another one. Again, write your places. So we have our hundreds column, our tens column, and our ones column. Our first number has 7 hundreds, 4 tens, and 2 ones. The next number has 3 hundreds, 8 tens, and 9 ones. So add your hundreds column, gives us 10. Add your tens column, gives us 12. And your ones column gives us 11. 10 ones makes an extra 10. And so that gives us a total of 13 tens. And we have 1 1 left. Bring down your 10 in the hundreds column. Remember, 10 tens makes 100, so that gives us 11 hundreds. We have 3 tens left, and bring down your 1. So again, we're trading 10 tens for 100 in the hundreds column. Now 10 hundreds is 1,000, so we need to add our thousands column to the left. And we're going to trade 10 hundreds for 1,000. I have 100 left. I have 3 tens and 1 1. So I have 1,131. In our next video, we'll look at adding in different bases. We'll talk about mental computation, and we'll talk about estimation.